Okay, and last little bit for 9C is us looking at adjacency matrices. Okay, so matrices are a compact way of communicating information in a graph. Okay, so you can represent a graph using a matrice, and it shows all the information that you would get from that graph. So they're just kind of different ways of representing the information. An adjacency matrice is a square matrix using zeros and integers. Okay, remember integers are positive whole numbers. So 0 or positive whole numbers to represent the information in a graph. Okay, so if we look at the graph below, we've got this one, our graph, and here's our matrice. So if we look at, is there a edge that connects A to A? No, there's not. So that's why there's a 0 here. So see how we've got A and A here? Okay, now if we look at, well, from B to A, there is one edge, so that's why there's a 1 here. Okay, if we look at, well, from C to A, again, there's one edge, that's why there's a 1. Okay, from D to A, let's have a look. From D to A, there are 2 edges, so that's why there's a 2, and so on. Okay, so let's have a look at this loop. From C to C, there is one way. So we look at C, and that's why there's a 1 here. Okay, so you can fill it all out, and you'll end up with this. This is your adjacency matrix to represent this graph. So some key features, okay, this part's very important, of an adjacency matrix is each non-zero integer represents a connection between the vertices. Okay, so non-zero, so these 1s and 2s, they tell us that there is a connection between the vertice, A, B, C, or D. A 0 indicates no connection. Okay, so if we look back up at the graph, I'll use a different colour. Back up at the graph, there's a 0 here, okay, and it's saying from B to B there is no connection. That's right, there is no loop, okay, from B to B, so that's why there's a 0. So there is no connection, so that's correct. Okay, the 1 in column C, row C, indicates a loop. So we looked at that before. This 1 here is from C to C, and yes, that's right, it is a loop. Okay. Adjacency matrices are always square, so that means we've got 4 letters across the top and 4 letters down the side, so that's a square. Okay, you might have a matrice and it might just be AB, AB. Okay, that's 2 by 2, which means it's a square. Okay, very important that you don't have, say, A, B, and C up here, and then A and B here. Okay, that is not an adjacency matrice because it's not square, it's then a rectangle. And another fun fact that I'm sure you'll all love, let me get a highlighter. Adjacency, so I'm looking at this last point. Adjacency matrices are always symmetrical above and below the leading diagonal. So top left to lower right. So top left to lower right are these ones. Okay, so if you look at either side of that line, you'll find that it's actually symmetrical. So let me show you. So looking over here, you've got a 0 and a 0. Okay, symmetrical either side of the line. Okay, you've got a 0 here and a 0 here. And then this diagonal, you've got 2, 1, 1, 2. So that's symmetrical. And you've got 1, 1, 1, 1. So it's all symmetrical. So you will always find that with an adjacency matrix. Okay, so just in summary, an adjacency matrix is a different way of communicating information from a graph.